3.3, proving lines are parallel. So let's start with looking over here at the right side. The problems we've been working on, traditionally I've said that line M is parallel to line N. And then I would ask you, well, given that these two lines are parallel, what can you tell me about angle A and angle B? Well, you would probably tell me that angle A is congruent with angle B because they are alternate interior angles. Well, we're doing the same concept today, it's just that we're going in the reverse order. So let me get rid of this guy. Okay, so in reverse, let's say we know that angle A is congruent with angle B. We're told that from the start. We'd like to prove instead that the lines are in fact parallel. So we're really going in the reverse order. Yes, these are alternate interior angles. If we're given the fact that they are congruent, then that's enough to say that, well, the lines must also be parallel. But because we went in the reverse order, we've actually used the converse of this statement. So we really use the converse of alternate interior angles. So we use the converse to say that lines are parallel. The norm is we know these two lines are parallel, so we can say angles are congruent. But the converse is used to prove that lines are parallel. So, some other examples. Given the statements below, what postulate's converse would prove that the lines are parallel? Again, note that we use the converse when we want to prove the lines are parallel. Looking at angles 1 and 8, well, here's angle 1 and here is angle 8. We're told that they are in fact congruent, and looking at them, they are alternate exterior angles. But since we're using the converse to say that the lines are parallel, we want to say alternate exterior angle converse. Okay. We're going to skip number 2. It's actually a bit of a trick question. Let's go to number 3. Angle 5 is congruent with angle 4. We'll find angle 5 and find angle 4. They're right there. They are alternate interior angles. If we're using the fact that they're congruent to prove that the lines are parallel, then we are using the alternate interior angle converse. Okay? And then let's go back to number 2. I said it was a bit of a trick question. I'm going to erase these marks. Number 2 says that angle 5 is congruent with angle 3. Now, if these two are the same measure, you might be tempted to say, oh, they're consecutive angles, so consecutive interior angle converse, right? But however, that's not the case, because consecutive interior angles, what that tells us is that angle 5 plus angle 3 are supplementary. So if they're supplementary, then we don't necessarily know if the lines are parallel unless they happen to be 90 degrees. For example, if the transversal is like this and they're both 90 degrees, then yeah, the lines must be parallel. But if they're congruent and they're not 90 degrees, for example, let's say they're both something like this, where maybe they're both 100 degrees. Well, I've still satisfied the fact that angle 5 and 3 are congruent, but the lines are clearly not parallel. So this isn't enough info. You won't generally get a trick question like this. Just threw it in here to get you thinking. So consecutive interior angles only works if they are perpendicular, if they're both 90 degrees. Okay, moving on. What value of A makes the line M parallel to line N? So here's M, here's N. What value of A would make the lines parallel? Well, these two angles would need to be congruent. So A must be 135 degrees. In the next example, again, these two angles must be congruent in order for the lines to be parallel. So 2a must equal 120. But the question asks for the value of a, so let's simplify here. Division property of equality on both sides, a equals 60. Alright. Moving on, you're going to do... Oh, the IXLs aren't in here. I'll stop it there.